Greetings and welcome to the very first video of ASMR Fundus, where we examine curious and interesting objects together. For the first installment, I decided to take a closer look at this strange rock I found during a walk through the woods. It was partially sunken into the soil. And most likely brought to the surface by rain and erosion. Right off the bat we can see that it has got some rather peculiar metallic sheen on one side, while on the other it looks a little more like a normal stone. Slightly weathered and with these cavities. The other thing, it weighs quite heavily in my hand, even more so than a normal stone would. All these properties together led me to the assumption that it must be some kind of slag or metal, maybe even some volcanic material. But even more exciting, the thought that this could be, in truth, a meteorite. So why don't we try to figure it out together? There are some tests we can do. First of all, inspecting its overall appearance. As mentioned before, it's looking very metallic on one side, with all the reflections we would expect from some iron material. But, and maybe you figured it out by now, there are these strange indents, like thumb imprints. If this object would be a meteorite, we would speak of so-called fragments, which are formed during entry into our atmosphere. On the other side, we have these bubble-like cavities. And these carvings looking like water erosion. I cannot make a definitive statement about these holes, but one possible explanation in this case would be terrestrial weathering, which means long exposure to rain, oxygen, and soil acidity. But I have to admit that I did not find any clear documented meteorite samples which would confirm this assumption. So I can only offer a careful interpretation of this texturing. Additionally, I have to say that these kind of cavities can also appear on terrestrial rocks. For example, volcanic stones or industrial byproducts. Like slag. So, what do we do? How about some more testing? I've got this special tool. It's some kind of metallic scriber. It's for scratching and piercing soft and hard surfaces to make markings on wood and metal. So what I would try to do is unveil what's beneath the rocky side of the object. If we would find even more metallic contents, it could be an indicator that this is in fact a meteorite or some sort of interstellar object. So let's try this. And sure enough, it seems like there are even more metallic flecks underneath its supposed stony crust. Let's take an even closer look. As you can see, those grains are quite reflective, which would indicate an completely metallic core. So I would consider our first two parts of the examination quite successful. We confirmed that the object has got some kind of crust comparable to a fusion crust with the typical rigmaclips of meteorites. It has got these weathering cavities, which confirm that it was buried underneath the soil for some time. And underneath, we uncovered even more metallic parts, which would confirm that it is some kind of iron meteorite or stony iron meteorite. And that brings us to the next test, which would be the most exciting one, the magnet test. For that purpose, I got some small but very strong neodymium magnets. So let's try to figure out how attracting this stone really is. Well, that was rather easy, but let's test some more. Let's put some more magnets around it. on the more soily side. They hold quite well and snap right onto the surface. Well, that wasn't supposed to happen, but that brings me to another form of testing. What happens if we stack them? As I said, these little magnets are quite strong and they defy gravity in any direction, as long as they are attached to this metallic stone. How about we test all the sides? And even if they have difficulties holding onto its rocky surface, they find their own place to hold on, as you can see. That's really interesting. Look at that. I can slide it around. And they stay strong on every side. There seems to be no difference in its attraction. The thing is, with these meteorites, if they have metallic contents, which they have most of the time, they will be magnetic always. That's because of their nickel iron combination. Well, I would consider this a roaring success. So let's get to our final test, which would be putting it on a scale. I measured its volume beforehand, which is important to calculate its overall weight compared to a normal stone. Normally, rocks, stones, minerals of any kind on this planet weigh between 2.4 and 3.5 grams per volume, so per cubic centimeters. Meteorites, on the other hand, and there are three types of them: stony iron meteorites, iron meteorites, and stony meteorites called chondrites. They weigh between 3.2 and even 8 grams per cubic centimeters. So let's put it finally onto a scale. So we got 382 grams. The stone overall has around 90 cubic centimeters in volume, which means roughly estimated around 4 grams per cubic centimeters for this object. Around 4. So, what does all of this mean for us? For the examination? Well, let's summarize again. We have got these metallic components all around its surface, weathering and these bubble-like cavities. These so-called fragments onto its fusion crust, if it would be a meteorite. we have got a magnetic reaction, a very strong magnetic reaction, I must say. And we figured out that its density is significantly higher than of any other mineral or rock on Earth. All of these results combined would, in my opinion, strongly indicate this rock to be, in fact, a meteorite, a stony iron meteorite. But what do you think? Could this be possible? Or do you think it's just some metallic waste or some kind of ancient mineral? I'd love to hear your thoughts on this matter. So feel free to comment if you want to. I hope this little examination sparked your curiosity, maybe even enough for you to come back next time and join me again for another examination of strange and mysterious objects. Thank you for listening, and until next time.